Hello friends, welcome to our third video in this channel. Today's theme is the design forces, how to calculate. There are three methods for the calculation of design forces as per a new code IS 1890-2025. So these methods we shall discuss one by one in details, and then we shall go to the application of the same through numerical in the next videos. So let us start today's video. We are on the seismic design forces computations by first method, equivalent static method. This is the part one of this design force calculation. So analysis methods given in the course are like this. I have given it as per IS 190-2016 and IS 190-2025. In 2016 there were four methods available: equivalent static method, response spectrum method, model time history method, time history method. In the new code, there are three methods only: equivalent static method, which is same as earlier, response spectrum method, and response history method. The first one is static in nature. It is trying to represent the earthquake forces in a static manner, equivalent static. The second and third are a dynamic process, dynamic analysis. So it requires model analysis, and then you can use the response spectrum method considering many modes. Remember, in the equivalent static method, we generally use only one mode, the first mode, in a particular direction. In the response spectrum method, you have to use many modes. How many modes we shall discuss. And in the response history method, you carry out the time history analysis and then go by the provisions of the code for further calculation of the forces. Now let us see the equivalent static method when it is applicable. For this purpose, we have taken a building plan here. There is a long direction of the building and the short direction of the building. This long and short will be coming again and again in our videos in the future. So let us understand. Equivalent static method, the first method of seismic analysis of the present code, is applicable when along the short direction of the plan, first translational mode gives mass participation 80% or more. So this is the conditional applicability of the equivalent static method. Similarly, along the long direction of the plan, first translational mode gives mass participation 80% or more. So these two conditions are required to be satisfied so that you can use the equivalent static method. Otherwise, you have to go to other two methods. Now, for the equivalent static method, the normalized design horizontal elastic peak spectral acceleration given by the symbol ANH at 5% damping is given here. These curves we have discussed in our first video. This horizontal at the PSA value is 2.5 and then parabolically drops down. There are three curves for the cyclus A and B, one curve, then cyclus C in the middle, and cyclus D at the top. So harder soil gives lower response, medium soil medium response, and softer soil gives higher response due to attenuation and other conditions. So these values we can use directly from the graphs here, or the code is also given the corresponding formulae to get these curves. You can use those formulae also. Suppose you are making a program. In that case, suddenly this graph will not help you. You can go to those formulae and utilize this in the program. Now, what are the steps to be followed in the equivalent static method of analysis? These are the steps. Prepare the model of the structure. A 3D model is recommended. It should represent the true geometry of the structure, all material properties including foundation soil properties to be fed in the model. The mass and stiffness shall be properly represented. The axial, flexural, shear and torsional deformation should be adequately addressed in the model. Soil flexibility to be modeled in the foundation soil. So for that purpose, code is given the stiffness of the springs of the soil to be used in the foundation. There are certain state vertical springs, some horizontal springs, some rotational springs. These spring constants are given in terms of the modulus of subgrade reaction of the soil. Time period, that is approximate time period used in the spectral acceleration values are the values given below. So for equivalent static method, you need not carry out the dynamic analysis for the capture of the time periods in different modes. However, a preliminary dynamic analysis is required to know the mode shapes, how they are playing. The first two mode shapes should be translational along the two directions, main perpendicular directions of the buildings, and third mode may be torsional. So for that purpose, a basic model analysis will be required, and you have to observe, you have to watch the mode shapes for the first three modes at least. Now let us see the time period, which is called approximate time period, to be used in the spectral acceleration values for the equivalent static method. This approximate time period is also called period caping, given in different codes. In our present code IS 1893-2025, period caping is the word is not used. The idea is this, that the structure should not be very flexible. This we shall see in our future videos. For the time being, let us see the time period formula, approximate time period formula given in the code. Design force calculation static method are given by this formulae. BBDH, B stands for base of the building, D stands for design, H stands for horizontal. So this is given by ZI ANH TH W R divided by R. So Z is the zone factor given in the code, I is the impedance factor attached to the structure, ANH is the normalized spectral acceleration in the horizontal direction corresponding to the time period TH along the horizontal direction. Because the code has separated horizontal and vertical responses in different formulae, so H is used for horizontal and B is for vertical. Now if the same thing, design force, is to be found in the vertical direction at the base, then it is termed as BDV ZIANV. Now the spectral acceleration is used in this vertical direction, time period in the vertical direction, seismic, W is the seismic weight. Seismic weight concept is known to you who have studied IS 1893-2016. It is the actual dead load in the system plus a percentage of the live load. This we shall discuss in our future videos. So this is the base shear force for which you shall be designing the structure. We shall distribute this force later on, we will see how to distribute. So these are the basic formulae for the computation of the base shear forces. Now let us see the time period formula given in the code. Since time period formula is given in the code, for equivalent static method, you need not capture the time periods of the model analysis of the structure. For the first case, still MRF buildings without brace, without infill. Infill means masonry infill, and MRF means moment resistant frames. So time period is given equal to TA equal to 0.085, H to the power 0.75, where H is the total height of the building in meter. Second case, RC steel composite MRF buildings without brace, without infill. This without brace, without infill, these are called bare frame. These are something like hypothetical, because in all the real buildings you will have the infill, and in many buildings you will have the brace also if it is steel building. So in the second case, case B, the time period is given by 0.08, H to the power 0.75. Third case, other buildings other than the RC MRF discussed above, which may have structural wall or may not have, which may have in the infill. URM means unreinforced masonry. URM means unreinforced masonry infill. So other buildings other than this, which are discussed in A and B cases, and this building can have shear wall, structural shear wall, and this building can also have URM infill. So these are not bare frames here. The time period is given by 0.09 H divided by D under root. H is again height of the building in meter. D is the dimension of the building in the plan in the direction concerned. So there will be two values of the dimensions of the plane in the long direction and in the short direction. Accordingly, you will get approximate time period in the long direction and in the short direction. Now, buildings with RC MRF with or without RC structural wall, with or without URM infills. Previous case was MRF buildings without brace infill, RC steel building without brace infill, and other than RC MRF will mean steel building, masonry building, with or without structural wall, with or without URM infill. Those are the cases. In the present case, buildings with RC MRF, with or without RC structural wall, with or without URM infill. So these are basically RC buildings, RC MRF buildings. You may put structural wall and you may put URM infills also. For these cases, the time period formula is lengthy, as given shown here. So there are several symbols used: rho CC, NCSW, I, CSW, LCSW, and rho MW. Let us see the meanings of all these symbols. H, height of the building in meter. Rho CC is structural plane density of all concrete columns at the base of the building in percentage. That is, find out the cross-sectional area of all columns divided by the total plane area. That will give the percentage column density. NCSW, number of concrete structural walls. How many walls are there? Rho CSWI, structural plane density of RC wall I at the base of the building in the direction under consideration in percentage. So each wall will be taken, its plane sectional dimension will be taken, divided by the plane dimension of the building will give you the structural plane density of the RC wall. This is rho CSWI, I for the ith wall. LCSWI, the length of the RC wall I at the base of the building. So each wall along a particular direction has length. So these are direction specific, you have to remember. Rho MW, structural plane density of the masonry infill alone at the base of the building in the considered direction. Masonry unit weight should be more than 12 kilonewton per meter cube to use this value, otherwise you cannot use this value. So in a particular direction you have so many infill walls, you find out the cross-sectional dimension of all the walls, add up. Then you divide by the plane dimension of the building, that will give the masonry wall density. This can be used only when the masonry unit weight is 12 kilonewton or more. Generally, masonry unit weight for brick masonry is 12 kilonewton per 20 kilonewton, correct. For the brick masonry infill, the unit weight is 20 kilonewton per meter cube. Now, taller buildings, this is actually covered in separate code, we shall see. When the building is more than 50 meter and it is RC moment resistant frame, then formula is T equal to 0.0644 h to the power 0.9. Then building taller than 50 meter other than RC, so steel building, masonry building of course will not be more than 50 meters, so it is actually indicating a steel building. T equal to 0.0672 h to the power 0.75. These are given in IS 16700 2023. This code is for the tall buildings. Now let us go to a new subtopic, the base shear genesis. What is the genesis of base shear? What is base shear? Let us try to understand. We have taken a three-story building here, with masses M1, M2, M3 in 3 floors upwards, and the acceleration suffered by the masses are A1, A2, A3. So by Newton's law, you know the inertia force generated will be M1, A1, M2, A2, and M3, A3. These forces at different levels, let us say as F1, F2, F3. These are lateral forces acting due to the lateral spectral acceleration. So if I add up all these forces F1, F2, F3, this has to be resisted by an opposite force at the base of the building. This is called the base shear force. This is base shear force. Now, these Bezier put formulae are given in different codes of international codes. I have shown here Indian 2016, UBC 1997, IBC 2006, Euro Code 8 2003, and New Zealand Code 1992. Most of the codes have been revised, and you can see the latest version too. In our IS 2016, the base shear was given by Z by 2 I by R SA by G W. Z is joint factor, I is impedance factor, R is response reduction factor, SA by is spectral acceleration ratio, W is seismic weight. In the new code IS 2025, it is changed to this format: Z I A N H T H W. ANHTH is nothing but just spectral acceleration in the horizontal direction, and response reduction factor remains as earlier. Only Z by 2, the 2 has been removed because Z has been categorized in such a way that design basis earthquake level need not be divided by 2. So other codes you can see. Now let us further go inside, drill inside from the Newton's law. What is Newton's law? It says the force in a system, force generated is proportional to the rate of change of momentum. So mathematically I give it F equal to d dt mb. So m is constant, I can take it outside. So F equal to m dv dt. B is the velocity and t is the time. So this is nothing but acceleration. So I can write F equal to mass into acceleration. A equal to dv dt. So this is Newton's law. Now, since inertia force has been generated at the mass level, which is F, this has to be counterbalanced by opposite force at the base, which I am telling as BV. So BV equal to MA. Now spectral acceleration we shall be mentioning again and again. Spectral acceleration, this word we shall be mentioning again and again, the basis of the, you can say, seismic design code. Spectral acceleration is the peak acceleration exhibited by a single degree of freedom system with sound damping under a given earthquake, symbolized by S suffix A. Let us take another, say, cantilever system with a stiffness K, mass M, and it is subjected to the force Fst, the inertia force, or you can say spring force. What is spring force? K into displacement will give you the spring force. We are using T in the both Fs and the base shear BB because with time these things will be changing because it is a dynamic system, dynamic forces. So using this symbol, m equal to mass K stiffness, ut equal to displacement response function, Fst spring force response, which is a function of time, then you can write Fst equal to K into ut because the spring constant is K, so K into ut. And we have the formula for angular frequency, omega equal to under root K by m. So if you square up both sides, you get K equal to m omega square. So we substitute this K here by m omega square. So this is the expression for Fst. Now let us see Fst equal to m omega square ut. And this omega square ut we shall designate by a new symbol for our convenience. This we are putting as Sat. And this is your spectral acceleration, which is changing with time in the dynamic system. Sat equal to omega square ut is the substitution we have made. So Fst has been converted in terms of m Sat. For equilibrium, Fst and BBT are same. So BBT equal to Fst equal to m Sat. For a particular instant of time, this is valid. In general, if we ignore this time parameter, then we can write BB equal to mass into spectral acceleration. So this is the way the base shear formula of the code, not only our country, all other countries are coming into picture through this dynamic background. So we have BB equal to MA into SA is the basic expression of base shear from the dynamics. Now this will modify gradually. Let us modify this. How we modify? Mass equal to W by G, I know, where W is the weight and G is the acceleration due to gravity. So this is converted to this. This we rearrange as BB equal to SA by G into W, because SA is spectral acceleration value, G is acceleration value. So if I take this ratio, it becomes non-dimensional. So BB equal to SA by G into W. This is the basic formula which we shall modify. So modifications are like this. We multiply it by the zone factor to get the level of the seismicity at the particular location of the structure, and divide it by 2 as per the previous code to take it to the design basis level. Then multiplied by importance factor I, because some structures are more important than other structures. For example, my building may be more important than your building. Then a response reduction factor. Why the response is reduced we shall discuss in the future videos. So it is divided by, so if you rearrange this, you get Z by 2 I by R SA by G into W. This was as per IS 193 2016. So what are the changes in the new code? Changes in the new code is like this. ZI same as earlier, ANH is nothing but SA, and TH means at that time period. TH is not a multiplier, it is corresponding to the time period you find out the ANH, spectral acceleration. W as earlier, R as earlier, only 2 is missing here. So because in the Z zone factor, these 2 etc. have been accommodated. So this is, you can say, a gentleman only in the new chart of the previous code. Thank you very much for coming with me up to here with this video. So in this video we have discussed the equivalent static method. We could not complete it, we shall continue perhaps in the next video. I wish your patronage of this new channel through your subscription, through your likes, through your sharing, and you are welcome to put your comments and queries in the comment box so that I shall be able to answer those, and I will be very glad to answer your question to the best of my ability. Thank you.